to find x-intercept is we should let y equal to 0. We take the equation and equal to 0, then we will solve the equation to get a value of x. The value of x-intercept is 1 over 4. Second, we will find y-intercept. We will use the same method as the way to find x-intercept. We should let x equal to 0 and then substitute the value of x with 0 and we will get the answer. The value of y-intercept is equal to 1 over 2.
Next step, find the vertical and horizontal asymptotes. What is asymptotes? An asymptote is a straight line that a graph approaches without touching the line. We have two asymptotes. It is vertical asymptotes and horizontal asymptotes. In order to find vertical asymptotes, step 1, we will let the denominator equal to 0. Step 2, analyze the asymptotes by approaching the value of x from left and right hand side. For the result, we got the one equal to negative infinity and the other one is positive infinity. Move to the horizontal asymptotes. We will find the limit of fx when x approaches positive infinity and negative infinity. So, how we are going to solve the limit by divide the numerator and denominator by the highest degree of x in the numerator. As simplified, if substitute infinity will become 0. So, we got the y equal to 4.
For question C, we need to find first derivative and second derivative. For first derivative, we use quotient rule. Formula of quotient rule is vu prime minus uv prime over v square. U equal to 4x minus 1 and u prime equal to 4. V equal to x minus 2 and v prime equal to 1. After that, we need to substitute in the formula vu prime minus uv prime over v square. Then, solve the equation and we will get the answer. The answer for first derivative is negative 7 over in bracket x minus 2 square. Second, for second derivative, we have to differentiate f prime x and we got f double prime x. The answer for second derivative is 14 over in bracket x minus 2 cube.
So the next steps in our working is to find the interval where fx is concave up and concave down. So in our previous working, we already found out that our f prime x equals to 14 over x minus 2 cube. So what we need to do next is to equate f prime x equals to 0. And after doing some calculations, we got that our x equals to 2. So after figuring out the value of x is equals to 2, we conclude that our intervals are negative infinite and 2, and the other intervals are 2 and infinite. The next step is to find the suitable test value for us to put into our f prime x. So after doing some calculation, we already figured out that intervals negative infinite 2 have negative numbers. So in conclusion, negative infinite 2 is equals to concave down, while intervals 2 and infinite has a positive number, which is equals to concave up.
To find the differential points is you have to refer the intervals. Okay, as you can see, the intervals that we got is concave up in the coordinate infinity 2 and the concave down is in the coordinate 2 negative infinity. So what we have to do is take the value of 2 and then substitute in the equation, in the fx equation. Okay, so when x equals 2, so substitute it, so you get f2 equals 4 times 2 minus 1 over 2 minus 2. Okay, so you get 7 over 0. That's mean undefined because 7 over 0, the value is infinity. Okay, so since the answer is undefined, so there's no inflection point in the graph. Okay. Okay, the next one is to sketch the graph. We have to reverse all the information that we get in the graph. We must have horizontal asymptotes and vertical asymptotes. Okay, now to sketch the red lines in the graph that shows, you have to follow the concavity that you have. In this question, the first red line, the concavity of the first red line is concave down. Okay, and the second one is concave up. So as you can see, the red line is not approached to the asymptotes. It is because in this graph don't have any minimum point and maximum points. Okay, because in this graph have infinity value. So that's from me.